It certainly will first in terms of direct connection to a power station. It's the first large-scale demonstration of direct boiling technology. That is, we produce steam directly in this solar collector. We produce steam at 275 degrees C, 50 bar. And that's the type of steam, temperature and power needed to operate turbines.
The technology works by capturing solar energy with reflective mirrors.
The tracking of the mirrors is controlled by a computer program that knows where the sun is at any moment in the sky, where the receiver is, and positions the mirror to be midway between the line from the sun and the line to the receiver. So there's a computer program that is positioning the mirrors throughout the day to keep the focal point onto the receiver.
The mirrors reflect solar energy onto the receivers positioned overhead. The receiver is made up of pipes filled with pressurized water.
These tubes are feeding very high pressure water into the receiver, 50 atmospheres, 50 bar pressure. The water, when it reaches the receiver, absorbs solar radiation and is converted to steam. By the time it gets 300 metres down the other end of the array, it's steam that can be fed directly to the power station.
Our technology is effectively just changing the boiler in such a system. Instead of using a nuclear boiler, we use a solar boiler. The solar boiler is very different in shape. It's maybe a square mile or 2 square miles or 10 square miles in size, but it's still just a boiler. And when you do that, you find that all of the other technology to make these things work is already there. It's all of the power station systems, people understand it in the utilities.
In order to roll it out quickly and cheaply, they designed it to function at relatively low temperatures. This allows them to use readily available and low-cost materials, glass, steel and mirrors that can last 30 years or more.
We found that there are a whole range of materials issues. Doesn't matter whether you're using pumps or whether you're using various types of materials throughout your system. Problem after problem became simpler operating at that lower temperature.